Tyndall effect. When a beam of light is thrown against a colloidal solution, the path of the beam is illuminated as a result of the scattering of light by the particles, and a blue cone known as Tyndall cone is observed. The Tyndall effect is caused by refraction of light by very small particles in suspension in a transparent medium. For any particle size, Tyndall effect will increase linearly with concentration. This means that the higher the concentration of the solution, the lighter the light beam is. The diagram shows the Tyndall cone when a light source passes through a colloidal solution.
Next, the Tyndall effect can also determine whether a mixture is a true solution or a colloid solution. The reason is because a true solution has smaller particles compared to colloid solution. Therefore, it cannot deflect light. Below is the examples of Tyndall effect in our daily life. For instance, the color of blue sky, visible rays of sunlight, light shine through milk, lots of dust in a lit up room, scattering of car light in a fog, and many more. For better understanding, let's watch 4 videos about Tyndall effect. The first 2 videos are the experiments that you can do at home, and another 2 videos are the examples of Tyndall effect in our surroundings.
Today, we're going to talk about the Tyndall effect. Named after 19th century physicist John Tyndall, it is an easy way to determine whether a mixture is colloidal or not. A colloid is a mixture with particles between 1 to 1,000 nanometers in size. Every colloid has 2 parts, the dispersing medium and the colloidal particles. The dispersing medium is the substance which the colloidal particles are distributed. For example, in muddy water, the dispersing medium is water, while the colloidal particles are the grains of sand and clay. For this experiment, we're going to need 2 glass bottles, one filled with water and the other filled with water and some soap. We're also going to need a flashlight. As you can see, when light is shown through the bottle with water, you can't see the beam of light passing. Moving to the bottle with the soap and water, you can see the beam of light passing through the bottle. This is what's known as the Tyndall effect, and it is caused by the reflection of light by very small particles in the medium. In this case, it's the soap particles in the water.
Hey, so what we're going to be talking about today is the Tyndall effect. Now, the Tyndall effect is a phenomenon where light scatters through a homogeneous mixture like a colloid or a very fine suspension, but it doesn't scatter through a homogeneous mixture like a solution. So this happens because the larger particles in a colloid or suspension scatter and reflect light, so the light's bouncing different ways, causing the beam to be big enough that it's actually visible to the naked eye. Think about like headlights passing through fog, right? You can see them, but only in fog where there's water particles suspended in the air. Now, this effect doesn't happen in a solution because the particles are actually too small. They're too finely distributed. And so the beam of light passes through the solution without being visible. So to illustrate this, I'm going to use a laser pointer. This is a laser pointer right here. And so we have 4 different substances. So I'm going to take the laser pointer and let's look at water. If you look at water, you'll see that you can kind of see the reflections on the glass, but other than that, you can't see the beam passing through it. Now for the vegetable oil, if you look at the vegetable oil, you can just barely see that beam passing through it. So, really not visible, and especially I have the lights down in here just so you can kind of see that beam. So not really that visible. Now we're going to take diluted milk, which is an actual colloid, and look at that. You can see that beam absolutely clearly. It's scattering enough of the light where the beam actually becomes visible. And so then now here you have flour and water. So what I'm going to do is I'm going to kind of shake this up a little bit so you can see. So it mixes it. And then let me see if I can get this. Yeah, look at that. And you can actually see the particles in the actual water too. So those are the particles of flour that you're seeing. So just to compare the last two, this is a colloid. It's more evenly distributed than a suspension, but not as evenly distributed as a solution. And then right there, you can see the actual particles. So that is the Tyndall effect.
Tyndall effect is a phenomenon in which a beam of light scatters on striking the particles present in its path. This scattering of light is responsible for the blue color of the sky. We know that our atmosphere primarily consists of oxygen and nitrogen particles, along with dust, smoke, and other particles in comparatively smaller proportions. The size of these particles in the atmosphere is responsible for the color of scattered light. When the sunlight strikes particles of dust, smoke, etc., which are bigger than the wavelength of sunlight, all the colors of sunlight are equally scattered. As a result, the scattered light appears white. However, when the sunlight strikes particles of oxygen and nitrogen, which are smaller than the wavelength of sunlight, the colors of sunlight having shorter wavelengths, that is, blue and violet, are much more scattered than colors having longer wavelengths. But our eyes are much more sensitive to blue color as compared to violet. Hence, the sky appears blue to us.